All right, so we're going to try another type of problem that we can solve by elimination. So this time, I'm looking at the system, and I know it's a system because I have these two equations, but I don't have a coefficient either on my x or my y that's the same and has opposite signs, so there's nothing on either of these that I could eliminate. I don't even have the same number, the same coefficient. So I'm going to have to pick either my x or y to eliminate, but I'm going to have to change not only the sign, but also the coefficient. And I'm going to work with my x's this time. You could do work with y's, it doesn't matter, you'll get the same answer. So if I'm looking at this -3, and I know that 3 times 3 is 9. So I could multiply everything on top by 3. But in order for this to become a positive 3, I'm going to have to multiply by -3. So when I do that, -3 times -3x gives me a positive 9x. And then -3 times 7y gives me a negative 21y, and that's all going to be equal to -3 times -16, which is a positive 48. Remember, you have to multiply every term by -3. I don't have to do anything to this bottom equation because I now have a term that can be eliminated. So I'm just going to rewrite it here. And when I do that, my 9x's cancel out. And I've got negative 21 plus 5y, which would be 16y, negative 16y, is equal to 48 plus 16, which would be 64. And if I divide by -16, my y would equal -4. So now that I've found that y equals -4, I'm going to come back to one of these two equations and substitute that in for y. I'm going to go ahead and put it in on the top one, I think. So I'm going to have -3x because I'm trying to now solve for x. So -3x plus 7 times -4 equals -16. So that means I have -3x minus 28 equals -16. And I'm going to add 28 to both sides. And when I do that, I have -3x equals 12. And when I divide, x would equal -4. So my solution to this system is -4, -4. That is the point where these two equations would intersect if you were graphing them. And you can always check it by substituting the numbers back into each equation.